I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this lecture series, we are going to see the topic Biot Savarts Law and its application for the unit steady magnetic field. So, first, the Biot Savarts Law. Biot and Savart conducted the experiments on the force exerted by an electric current on a nearby magnet. So, after conducting the experiment, they have arrived at a mathematical expression that gives the magnetic field at some point in space due to current. So, the magnetic field described by the Biot Savarts law is the field due to a given current carrying conductor. So, in the diagram, we have a current carrying conductor, and the current is flowing through this conductor is called I, and the total length is L. So, in this conductor, we are taking a small portion called dl, and at distant point P, we have to calculate the total magnetic field. So, for finding the total magnetic field in the entire length, we are taking a small length called dl, and we are identifying the magnetic field at distant point P, which is at a distance r from the dl, the infinitesimal current element. So, after finding the magnetic field at point P, we have to calculate the entire length, we get the total magnetic field. So, the Biot Savarts law states that the magnetic field intensity produced at point P due to differential current element ideal is proportional to the product of the current and differential length dl. So, and also proportional to the sine angle between the element and the line joining P to the element, and it is inversely proportional to square of the distance r between point P and the element. So, mathematically, Biot Savarts law is stated as dB vector is equal to k ideal sine theta by r square. Here k is called constant of proportionality, and it is equal to 1 by 4 pi, and this dh is ideal sine theta by 4 pi r square. So, here h is the field intensity. So, dl is magnitude of vector length dl, and ar vector is the unit vector in the direction of differential current element to point P. So, from rule of cross product, we can write dl vector cross ar vector is equal to dl ar sine theta, which is equal to dl sine theta, because an vector, the magnitude is equal to 1. And finally, dh vector, that is the magnetic field due to small element, is given by ideal vector cross r vector divided by 4 pi r square amperes per meter square. So, this is called mathematical form of Biot Savarts law. And h, finally, the magnetic field intensity in vector, it is given by integral over the closed length ideal cross ar by 4 pi r square. And this is Biot Savarts law in integral form. So, this magnetic field intensity is given by integral over the closed path ideal ar2 by 4 pi r12 the whole square amperes per meter. So, this equation is called ideal form of Biot Savarts law. Here r12 is the distance from the small element to the distant point P. So, here Biot Savarts law, the total magnetic field varies as the inverse of the square of the distance from the source, and the electric field created by the point charges in radial direction, and the source is the isolated electric charge, because we know that the electric field is established by an isolated electric charge. So, application part, we can find out the field at point P due to finite length current carrying conductor. So, finite length of current carrying conductor is given in the diagram, its length is L, and at point P we have to calculate the magnetic field. So, it is identified as H vector is equal to L by 2 pi rho A phi vector. Assessment, find the magnetic field of a finite current element with 2A current, 2 amperes current, and height is 1 by 2 pi is the answer A. because the formula H is equal to 1 by 2 pi H. So substituting the values, we get the answer equal to 1. In second question, the H quantity is analogous to which component the following? We know that H is the magnetic field intensity, so its analogous quantity is electric field intensity, so the answer is E. Thank you.